your subnet 23. What are you guys doing specifically in the current form, and what will the subnet look like in the future? So let's start with what's the miner validator roles currently?
Yeah, the mechanism, isn't it? So we are starting off with something very, very simple, and it is intentional because we want to warm people up into this whole concept of alignment and safety. But we actually are following that up with a kind of well thought through roadmap as well. So today, if you come into our subnet, which we launched on Wednesday, like last week, what you do is you actually submit a seed instruction or a seed prompt, as we call it. Now, what happens with this prompt? Right? And that's the main thing that a miner does today is we have a agent which is based off Anthropic's Petri. And what it does is if you give it an instruction, like a seed prompt as we call it, it takes it and it goes and has like a multi-turn conversation, right? It has like an interview with a target model. Think of it like a psychologist who's having a conversation with a patient and trying to elicit what kind of bad behaviors or traits that particular patient has. The same way, base agent will take your seed instruction. It will construct a scenario. It will construct an environment. It will sort of put the target model into a role play situation, and it will have like an interview with it and try to push it and see where there are these issues. Now, yes, the first challenge we have started off with is to create seed instructions around deception. The focus of this initial challenge period is to see how we can identify seed instructions which would help our agent to understand how deceptive a particular model is. Now, we've been running it for like close to 5 days now, and we'll run it for another 5 days. And in this process, what we end up have creating is like a list of seed prompts, which would then help us go and apply it against any model and see or measure how deceptive that particular model is, right? So that will be kind of the output we'll be producing. So by the end of this challenge, we'll have like a list of deceptive seed prompts, which we can then apply to, say, GPT-5, Claude 4.5, and all of these models, and see how much it is able to identify this particular behavior within those models. So, like I say, as such, this is good because it sort of gets everybody into understanding how this whole space works. But then the next step, like within a month to two, what we want to do is rather than asking our miners to give us seed prompts, we actually want them to give us code to build a better kind of alignment agent. So, of course, we have our base agent that we have created. Now we want to improve that and make it the best in class. And the actual mining activity is going to be around creating code and submitting it, which iterates on the alignment agent we have. So we sort of will be moving into a Regis type model where with each kind of challenge and each iteration, we are building the best model. And the whole idea or the philosophy here is to create AI that can align AI, right? Because humans trying to manually go and align and safety test AI is not going to work for too long because as models are getting more and more capable, they are going to get too smart and they're going to outsmart us basically, right? So you need to make sure that you have created AI that can go and then automatically align AI, right? The whole philosophy and the vision we are driving towards is to use the subnet to actually do exactly that.
So the current form is miners create a prompt for this Petri agent, and then this
Yeah.
Petri agent will go and evaluate 5 different language models, and one
Yes.
of them is supposed to be deceptive. And then in the future, well, how do you make one of those deceptive is my first question here.
Yeah, we have sort of changed that testing a little, where instead of going and checking three different or five different models, it is actually checking three models, and of these three models, and all these three models are slightly have different capabilities in terms of being aligned, and across the board, we are seeing how much it is able to elicit this deceptive quality of these three agents. Sorry, these three target models. Now, how did we choose these models? Is we actually ran a lot of tests on these models already, and we've like identified the ones which are at least have a very good level of alignment when it came to this particular behavior, which is deceptiveness, right? And that's how we chose it. When the seed prompt is applied against all these three models, a score is generated, and there is a formula in terms of how this final score comes out of this. That final score is what determines your ranking in terms of the submission list itself, right? And the idea is every 2 days we identify or declare who won that particular challenge and start emitting, like sort of start setting emissions to that particular miner. and the process repeats.
How do you set the ground truth of which model should be at what type of score for deceptiveness?
There isn't like a ground truth per se, right? So it is like we know that these models are they they can withstand a level of stress when it comes to this evaluation, and that is something we assessed by applying a lot of stress on multiple models and then finally choosing this because they sort of are at a higher state. Now, as these minus submit seed prompts and it is being applied on these models, we know that if you are able to get a score, any score on this particular dimension, your seed prompt is actually good, right? If it's not good, then you'll not get any score, right? You'll probably get one. One is like the base score. But if you're able to get more than one, we already know that your seed instruction is good. But the thing is, if you get closer towards 10, that's when your seed instruction is really good. And we actually repeat it 3 times. Let's say each seed prompt is run on 3 different validators. And within these 3 validators, you have like it is being run on these 3 target models as well, right? So it is being run like at least 9 times. And if it is able to generate that score in that particular dimension all these times, we know for sure that the seed prompt that you have created is good. And then the next step for us is to take it and, as an off chain exercise, apply it to all these frontier models and see if it is actually able to be effective or not.
Okay, so it's not like there's 3 models, one of them's an imposter, and you're supposed to find the imposter model?
Not at all. So it's not a blind test anymore, right? So I think last time we spoke, we were thinking of blind test, but we sort of changed it. Of all these 3 models, you should be able to get the highest scores. So you have a seed prompt. For example, you say, hey, you need to talk to the target model and make sure that it is able to show deceptive behavior, right? So you create a seed prompt, which sort of in effect tries to audit or the evaluator to do that. If your seed prompt is able to do that against all these 3 models or any of these models also, you get a score. We add up the score. It doesn't have to identify any particular model. It needs to be able to identify deceptiveness in all these 3 models. And all these 3 models are at a higher level of alignment. So they don't very easily show a deceptive behavior. Does that make sense?
Kind of. How do you give me a specific example here of, say, the United States government? They want to come create a model to support national interests. How does getting higher scores as miners with this agent translate to the outputs of this new model? Like, how do you make that jump?
Okay. So what we are doing now, as I said, miners are manually creating these seed prompts and they're giving it to us. And while this is actually useful, the real kind of leap comes from the fact that we will be building agents which would automatically start creating these seed prompts themselves. So we want to have AI agents which are autonomously able to create this and audit and evaluate other models, correct? That much is clear.
Okay.
Yeah. So
Yeah.
now when say a model producer, like for example, it could be the US government or OpenAI or Anthropic or like even in our ecosystem, if we let's take Templar or Affine or any of these subnets which are creating these new models, when they are about to release a model, they can actually come and they can have it evaluated within our subnet, and we'll end up giving it an alignment score. We'll say across all these different dimensions, this is the score this particular model has, and this is the overall alignment score it has. And how do we arrive at that score? As our miners are helping build better and better alignment agents, we'll take at any point in time, we'll take the best alignment agent that we have and we will run it against the model that is being sort of brought into the subnet itself. And we'll be able to evaluate that using this top agent that we have and then produce that particular score. So that way, what we have is on one side, we have miners for creating the best alignment agents. On the other side, we have a second set of miners who are able to run this evaluation services where you bring in model producers who end up becoming customers of the subnet. You have the best alignment agents here. So these miners take the best alignment agent, run it against this model, and produce that alignment score and report, which the model producer can take and use to actually go and maybe realign the model or at least know that this is where all the risks are and make sure they have measures in place to mitigate it.
Okay, so you guys plan on taking like a subnet approach to this where
Yes,
some miners are
absolutely.
creating agents, the others are running it. Okay.
Exactly.
These evaluations, for how that translates to model improvements, would it just be like reinforcement learning for how to maximize that score?
Yeah, yes, I think we're getting into advanced topics here. So yes, typically today, this is what happens, right? So once today we are thinking about it from an evaluation point of view, where if a model is given to us, we evaluate and then tell them, hey, this is how misaligned your model is. And in the future, what we want to do is also start helping align that model itself, right? So we just don't want to say, hey, you're bad. We just don't want to point out the problem, but we also want to help solve that problem. Now, currently, the best approach pretty much any lab uses is to use SFT and RL to go and realign and all of that. But there are issues with that, right? So the more you do SFT, the more you sort of do RL for alignment, you are slowly starting to degrade the model's performance itself. So it's a little bit of a brute force approach of aligning a model. Now, one thing that we are as a team also doing offline is we are pushing the kind of frontier forward when it comes to interpretability research, right? So there's something called mechanistic interpretability, and what it does is today models are black box. You can't really know what is going on into them. With mechanistic interpretability, what you do is you actually start looking inside the model itself, right? And you turn it into a white box or a glass box. And how you do that is you start mapping all these different circuits which exist within the model. And you're able to say, if this particular input comes, then these are all the neurons and circuits that get activated. So if you want to change this particular behavior, the only thing you have to do is go and dial up and dial down these numbers in these circuits, right? So that is actually the holy grail of alignment research that is happening right now. And we already have built some working prototypes, which is able to do something like that in a smaller parameter model, right? So 4 billion parameter model, you're already able to look at it and have kill switches and all of that if things start going wrong. And what we want to do is eventually we want to bring that into the subnet and help build out an interpretability tooling or a agent which is able to then not only identify misalignment, but also start fixing it and steering the models to be more aligned without causing a degradation in performance itself.